Hey guys, like I told you, we are going to focus on SAT and SAT prep, and to get you started, we're going to start reviewing rules of exponents and looking at scientific notation, because you'll see both of them when it comes to the SAT and ACT. So first rule we're going to look at is product of the powers. When multiplying two numbers with the same base, so if we're looking at exponents, this 5 is the base. 2 is what you're raising that power to. So this is our exponent. If we're multiplying two numbers with the same base, you add the exponents. So same base, add exponents. So in this example, the bases are 5. Our exponents are 2 and 6. So our base will stay the same, and all we're going to do is add 2 and 6 to get our exponent. So this will be 5 raised to the 2 plus 6, which is 8. Let's look at right here. The power for this one, if it's not written in, it's raised to the power of 1. So all of our bases are the same. They are all y's. So that'll be our base. And then we're going to add all these exponents. So we're going to add 4, 3, and 1. So this will become y to the power of 4 plus 3 is 7 plus 1 is 8. I'm going to have you try this one on your own. Let's look at one very similar right here. So you're going to add like things. So we have our numbers, -3 and 5. We're going to multiply them because right here we have two parentheses next to each other. Two things next to each other means multiplication. So we're going to multiply -3 and 5. Then we're also going to look at our x's. Remember, this is raised to the power of 1. So we have x squared times x1. And then we have our y's. Y to the 7th and y to the 6th. So now we can simplify these. -3 times 5 gives us -15. For our x's, remember we add our exponents. Again, for the y's, we're going to add the exponents. And now we can finally simplify. X raised to the power of 2 plus 1 is 3. Y to the power of 7 plus 6 gives us 13. And this is our final answer. So now let's look at a quotient of power. So this is when we are dividing. It's when we're dividing, and what we're going to do now, they have the same base. We are going to subtract the exponents. So what this looks like, I have y is my base, and now I'm going to subtract. We always start with the numerator. So it's 6 minus, and remember there's a 1 here. So 6 minus 1, our base is still y. 6 minus 1 gives us 5. I'm going to let you try this one on your own, and let's look at this one. Again, just like we did up here, we're going to combine like things. So let's look at our numbers. We have, and I'm going to put just a generic division sign. We need to simplify 10 over 15. What number goes into both 10 and 15? It's 5. 5 goes into 10 twice. 5 goes into 15 3 times. So this is going to be 2/3. And now we subtract our exponents. So let's look at our a's. So we have a 7 minus 5. And then we look at our b's. We have 9 minus 9. Let's do our final simplification. We have 2 over 3 still. 7 minus 5 gives us 2. And 9 minus 9 is 0. And anything raised to the 0 power is 1. So this actually becomes 2a squared over 3. Because 1 times all of this is still this. That 1 kind of just disappears. So this is quotient of a power, or of powers. A couple things to explore is that a zero exponent, so when we have any base raised to the power of 0, it becomes 1. And if we look at here, this is still 8, 2 minus 2, which gives us 8 to the 0 power. Here's why it's 1. I know that x over x is 1. I know 25 over 25 is 1. I know that 2a squared over 2a squared is going to be 1. So if I am 8 to the 0 is the same thing as 8 to the second over 8 to the second. So these are the exact same thing. So anytime I have a number over itself, it's 1. Same thing is going to happen when I have 8 to the 0 power, or base to the 0 power, it's going to be 1. So this is why that works. So if we look at this example, all of this in parentheses is being raised to the 0 power. So this entire problem is 1. And that's it. Because the 0 is being distributed to everything in parentheses. If I look at this one, I don't have parentheses. So my 8 stays the same. The only thing that this 0 is for is the x, because there is no parentheses. So that'll be a 1 plus 5. 8 times 1 is 8, plus 5 gives me 13, and that's my answer. Another interesting exponent is if it's a negative. For any non-zero number raised to a negative exponent, you place the power in the denominator and rewrite the power as a positive exponent. So I'll show you what that means. If I have b to the second minus 5, what I end up getting is b to the negative 3, and we don't want a negative exponent. So if you think about it this way, which exponent is bigger? This 5. So I know that my answer is going to end up in the denominator, because that's where the highest powered exponent is. So 5 minus 2 is 3, so this will be 1 over b to the third. It's telling me that I'm going to move this entire thing down to the denominator, and then I'm going to change this power to a positive. So I'll show you what that means. I have 2 to the negative third. What this is telling me, and we'll just start with the negative, is that I want this now to be a denominator. So this negative moves it all the way to the denominator and changes the power to become a positive. Now I can finish. 2 times 2 is 4. 4 times 2 is 8. And that's my final answer. Same thing with this one. It's going to both. So this will be negative 3 to the positive third power. If I multiply a negative by itself 3 times, it's still going to be negative. So my answer is still going to be negative, and 3 to the third power is 27. Keep in mind that if you are raising a negative to a positive power, so if I have negative x squared, it's not going to be a positive x, because it's the same thing as negative times a negative, which equals a positive. Because it's this is 3 times, I have negative times negative times negative. So a negative times a negative makes it a positive. I multiply by a negative. I'm still left with a negative. So that's why this negative stays.
Yes.
All right, 2 more properties of exponents we need to discuss. One is a power raised to a power. And when you're doing this, you will multiply the exponent. So in this case, x is our base, that stays the same, and then all you're going to do is multiply your exponents. So 2 times 8 is 16, and that's your answer. Let's look at this one. Our base is y, and then you multiply the exponents. Negative 3 times negative 4 gives me y. Negative times a negative makes this positive. 3 times 4 is 12. When I look up here, I see I have a whole bunch of stuff in the parentheses. What this means is that we're going to distribute. So we're going to distribute this 3 to each piece. So I have 4 to the third. X to the 3 times 3, y to the third, z to the third. And now we simplify. 4 cubed, so we do 4 times 4 is 16. Times that, times 4 again gives us 64. 3 times 3 gives us x to the 9, and then the y and z are both raised to 3. Now have you try this one on your own, and let's take a look at this one. Again, you're going to distribute to each piece. So we have 6 to the negative 2, x to the negative 6 times negative 2, y to the negative 7 times negative 2, z to the 0 times negative 2. And from here, we simplify. The negative in this tells me that this is going to be in the denominator. Then I have, we'll finish this in a second, negative 6 times negative 2, negative, make it positive. 6 times 2 is 12. Then I have y, again, negative times a negative is a positive. 7 times 2 is 14. And then I have z, 0 times anything is just 0. So we'll finish simplifying this. 6 squared, 6 times 6 is 36. And I'm going to put it all over this. It's the same thing. I have my x to the 12th power. Then I have y to the 14th. And 0 exponent always equals 1, so I don't need to write it. So this is my final answer. Again, the same thing occurs here, even though I have a division or a fraction. So we're still going to distribute this 2 to both pieces. So we get 3 squared over 5 squared. 3 squared is 9. 5 squared is 25. And as I said, very similar. I'll have you try these two. Look at this last one. It goes to each piece. So I have a to the negative 2 times negative 6. B to the negative 5 times negative 6. C to the negative 11 times negative 6. And what I noticed already is that all of these are going to become positive because they're all negative times negative. So this will be a to the 2 times 6 is 12. B, 5 times 6 is 30. C, 11 times 6 is 66. And I have already simplified. Last thing we're going to look at, and this won't take long, is scientific notation. The standard way we write our numbers is just long and drawn out. However, scientific notation simplifies things. So we can write 208 million like this. What this says is we take our decimal, which we know that there's a decimal at the end of every number. All we're doing is moving this decimal over till we get 2.8 and counting. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8. So however times I move my decimal is what you're raising 10 to. It's always going to be a power of 10. So this number will always be 10, and this is what you move your decimal by. So if we look at an example, I know that if I'm going to move my decimal this way, it's going to be positive because I know I have a big number. If I move it this way, I'm going to make it negative to show that this is a decimal, that it's less than 1. So for this example, we move it over once, twice, 3 times, 4, 5 to get 4.2. So I moved it over 5 times, so it's 4.2 times 10 to the 5th power, because this is how many times we moved it. If we look at this example, how many times do we move this decimal over? 1, 2, 3, 4, 5, 6, 7, 8. So 8 times, that's my power. For this example, I know that I'm now going to the right. I'm showing that I have a decimal, so it's going to be negative, and we move it over 1, 2, 3 times, so it's to the negative 3rd power. Lastly, do it one more time. 2, 3.